Aniruddha, you may start with full screen and please introduce yourself.
Okay. So good afternoon, everybody. Uh, so the last session of the today is the introduction to the TCP IP, and myself Aniruddha Datta, the project engineer in CEDA Kolkata. So the last session of the TCP IP, that is the theoretical session, so that I will go through the different layers, the layered architecture of the TCP IP and the OSI model. So the outline is like that. We first go through the OSI, introduction to the OSI, then we go through the OSI history, then we go through the OSI layers, then we come to the TCP IPs and the TCP IP layers, IP address, and the DNS basic concepts. So this is the outline of the total PPT that we will be going to discuss in the next 1 hour session. So as you know that OSI is one of the basic architecture. The OSI, the Open System Interconnection Reference Model is, one second, is a description for the layered communication and computer network protocol and transmission design. It actually divides the data movement into 7 layers from top to bottom. They are application, the presentation, session, transport, the network, data link, and the physical layers. So it is therefore referred as the OSI 7-layer model. So actually OSI, Open System Interconnection, is a networking architecture model by which actually different equipment standards can actually communicate to each other. So it is one of the basic architecture model, and by which the networking standards are actually based on. So and there are 7 layers are there: application layer, the presentation layer, session layer, the transport layer, network layer, data link layer, and the physical layer. In the OSI history, we see that in 1978, the ISO, International Standard Organization, began to develop its OSI framework architecture. So it was developed by the ISO, International Standard Organizations. So the concept of the 7-layer protocol or the model was actually provided by the work by the Charles Bachman, then of the Honeywell. So it is the idea of the Charles Bachman, then the 7-layer model come into place. Various aspects of OSI design evolve from the experiences, and that comes to the development of the ORPANET. ORPANET actually is the Advanced Research Project Agency Network, and ORPANET is actually responsible for developing the TCP/IP protocol. So first, the ISO actually conceptualize, the International Standard Organization actually conceptualize the layers of the OSI, and then when the OSI layers are actually modeled, then with the concept of the OSI, the ORPANET, which is the premier one in actually developing the internet, also the TCP/IP architecture protocol. So OSI layer and the TCP/IP layer, these two are actually the same one, but there are some basic actually differences are there. But the conceptual is it was actually a logical and conceptual model. The OSI layer is actually a logical and the conceptual model, and the basic objective of the OSI layer is how do the communication happens between different manufacturer network nodes, because every network manufacturer or every equipment manufacturer has a different standard or a using the different protocol. So to give them a common platform, the OSI layer actually comes into play. So this is actually the 7 layers of the OSI. So we start from the down, that is from the physical layer. The physical layer where the data unit is the bit and the function is the media, signal, and the binary transmission. And the second, we have the data link layer where the data unit is frame and where the function is the physical addressing. The third one, that is the network layer where the data unit is packet and where the function is the data actually the path determination and the logical addressing. So in the network layer, actually we have all the network layer equipments like the router or the which works actually on the IP address that actually works in the network layer. So the network layer is one of the vital layer in the OSI model. Then we have at the layer 4, that is the transport layer, where the data units are the segment and the function of the transport layer is the end-to-end connection, reliability, and the flow control. And the 5, 6, and 7 that all have the data units are the data, the session layer, the function is the inter-host communications, the presentation layer, the function is the data representations, encryption, and the decryption. And the topmost layer, that is the application layer, that actually works on the, that actually function as the network process to the application. So these are the 7 layers of the OSI model. So there are 2 parts are there. One part of the segment is called the host layer, and the second part of the segment is called the media layer. So we come from the first, that is the physical layer. The physical layer actually defines the electrical and physical specification for the devices. So it is the first layer, and it actually defines the electrical and physical specification for the devices. In particular, it defines the relationship between a device and the physical media. So the network device, the devices that works in the physical layers are the hubs, the repeater, network adapter, host adapter. These are the devices that works in the physical layer. And here the transmission mainly occurs in the electrical or the electromagnetic transmission, and only 0 and 1s are actually transmitted. The major functions and the services performed by the physical layer are establishment and termination of a connection to a communication medium. So here the main function is here we can establish the connection, also we can able to terminate. So the establishment and the termination is actually done by the physical layer. And here the signals are being sent or received in the form of zeros and the one. So it is the basic layer where we can able to send the signal or we can able to transmit the signal. And here we have the network devices that works. We have the devices that work here, hubs, repeater, the basic level devices, hubs, repeater, the network adapter. So this is the function of the physical layer. Second one is the data link layer, where the data unit is the frame. In the physical layer, the data unit is the bit. So it is actually transmitting 0 or 1. In the data link layer, the data unit is the frame. The data link layer provides the functional and the procedural means to transfer data between network entities and to detect and possibly correct error that may occur in the physical layer. So the MAC address, we know about the MAC address because it is one of the useful address to to actually define the manufacturer of the network adapter or the different network equipments. So MAC address is actually used at this layer, and the devices that function in the data link layer switch. The switches actually functions in the data link layer. The layer 3, that is the network layer. The network layer provides the functional and the procedural means of transferring data from a source to a destination via one or more network. So network layer is one of the most important layer because it will give the end-to-end delivery of packets, because here the data units are the packets. So from one node to the another node, the packet delivery is actually done by the network layer. The network layer functions, the network routing function. Network routing function. Routing means whenever there are different networks are there, so to send one packet from a single network to a different network, so we need to have the function of the routing function, and the routing function is actually done by the router. So here the router operates at this layer. Router operates at the network layer, sending data throughout the extended network and making the internet possible. Because all the IPs and all the IP related protocols that works in the network layer. And fourth one, that is the transport layer. The transport layer provides transparent transfer of data between end user and the providing the reliable data transfer services to the upper layer. And the transport layer controls the reliability of the given link through flow control, segmentation, and the error control. The main function is the flow control, segmentation, and the error control. And here in the transport layer, two main protocols actually works, TCP and the UDP. This is the main protocol, and which is the basic fundamental of the internet also, because the TCP and UDP on which the internet is actually based on. Next, we have the session layer. The session layer controls the dialogue, that the connection between the computer. It establishes, manages, and terminates the connection between the local and the remote application. So the network layer actually operates between the one node to the another node. That means one computer to the another computer. But in the session layer, it's actually the one application to the another applications. It actually controls the dialogue or the connection between the computer. So the connection establishment, the connection failure, that is actually the function of the session layer. It establishes, manages, and terminates the connection between the local and the remote applications. And the layer 6, that is the presentation layer, which is also known as for its function is the encryption. The presentation layer establishes a context between the application layer entities in which higher level entities can use different syntax and semantics, as long as presentation service understand both and mapping between them. So it is actually does the mapping between the different syntaxes and make them a common syntax. The layer provides independence from differences in data representations, that is the encryption, by translating from application to the network format. This layer format and encrypts data to send across a network, providing freedom from compatibility issues. It's it is sometimes called the syntax layer because it actually works with the presentation layer is actually works with the different syntax, different level, and come them to the common format. So that is why it is called the syntax layer. And the one of the major function of the presentation layer is the encryption. Okay. So then the topmost layer, that is the application layer. The application layer is the OSI layer closest to the end user, which means that both the OSI application layer and the user interact directly with the software applications. Application layer actually functions identifying the communication partner and identifying the resource availability. So it is the topmost layer, and some of the common protocols here that is very common: HTTP, FTP, SMTP. So the user level protocols are actually works in the application layer. So it is the topmost layer, and users directly communicate with this layer using the protocols. So now we come to the TCP IP. After we have a brief idea about the 7 layers of the OSI, Open System Interconnection, next we come to the second model, that is called the TCP IP. That is actually come into play by the ARPANET, and ARPANET is uh, actually the inventor or the basic standard maker for the internet. So what we see today in the internet, that is because of the research of the ARPANET, and the internet actually follows the TCP IP model. Internet follows the TCP IP model. So so it is the protocol name suite, the TCP IP, transmission control protocol, or the /IP, internet protocol suite, is the set of communication protocol used for the internet and other similar network. So the TCP IP is mainly developed for the purpose of the internet, and it is named from the two of the most important protocol in it. First one is the transmission control protocol, another was the IP protocol. Whether the transmission control protocol is the connection oriented protocol, and the IP is the connectionless protocol. So the TCP IP, what is the TCP IP? It is a set of protocols developed to allow cooperating computers to share resources across a network. So it is the protocol, means a set of standards to allow computers to share resources across a network. TCP stands for Transmission Control Protocol, and the IP stands for the Internet Protocol. So that they both are the transport layer and the network layer protocol, respectively, of the protocol suite. The most well-known network that adopted TCP IP is the internet, that I have already told you, because internet is based on the architecture of the TCP IP. The biggest WAN in the world, that is the internet, that actually adopted the standards of the TCP IP. WAN means wide area network. So the TCP IP is actually adopted in the internet. So what is the protocol? A protocol is a collection of rules and the procedure for two computers to exchange the information. So it is the set of rules and the procedure so that the two computers can communicate to each other. Protocols also defines the format of data that is being exchanged. So in the protocol also, the standards and the format are mentioned, that if you use this protocol, you need to follow this format of data, so that a common format is used across the different networking equipment vendor, so that there is no proprietary format comes into play. A common format comes into play, and across different network vendors, they can able to communicate. So the TCP/IP model, you know that OSI is a 7-layer model, whereas the TCP/IP is a 4-layer model. So these are in the left, we have the 7 layers of the OSI. In the right, we have the 4 layers of the TCP/IP. So in the TCP/IP, we have the 4 layers, that is the link layer, internet layer, transport layer, and the application layer. These are the 4 layers in the TCP/IP. So if you see that, if you make the comparison between the OSI and the TCP/IP, so you see that in the TCP/IP, in the link layer, that is actually composed of the 2 layers in the OSI, that is data link layer and the physical layer. And the network layer in the OSI is actually called internet layer in the TCP/IP. The transport layer is same in the 2 of the architecture, but here in the application layer in the TCP/IP is actually comprised of the 3 layers in the OSI, that is session layer, presentation layer, and the application layer. So the layers are compressed and compacted to have a much more robust architecture in the TCP/IP. Then we come to the TCP/IP. The first one is the application layer protocol. Application layer protocol, that is the first layer of the TCP/IP. Application layer protocol, where you see the protocols that are running, that is the telnet, FTP, SMTP, POP3, SNMP. So these are the common protocol that use in the applications layer. So application layer, the protocols define the rules when implementing specific network application, and it rely on the underlying layer to provide accurate and efficient data delivery. So the function, so the basic motto of the each layer is to provide accurate and efficient data delivery. And the protocols that work in the application layer, that are mainly FTP, that is the file transfer protocol, that is used for the file transfer. Telnet, that is the remote terminal protocol, that is used for the remote login. SMTP, simple mail transfer protocol, that is used for the mail transfer. HTTP, hypertext transfer protocol, that is used for the web browsing. So these are the common protocols. There are other protocols also. So these are the common protocols that works in the application layer of the TCP/IP. So next, after the application layer, the TCP/IP have the transport layer. The transport layer protocols, the TCP/IP is built on the connectionless technologies. Each datagram finds its own way to its destination. So it is the connectionless. So that is why each datagram, a data unit in the TCP/IP is called the datagram. So each datagram finds its own way to its destination. That is why it is called the connectionless protocol. So transport layer protocol defines the rule of dividing a chunk of data into segments and reassemble segments into the original chunk. So that is the protocols. It actually defines the rule how to divide a chunk of data into segments, and when they are actually at the receiving end, then reassemble the segments into the original chunk. So this is the function of the transport layer. And here the major protocols are the TCP and the UDP, transmission control protocol, and the user datagram service, user datagram protocol. So these are the main protocols in the transport layer. Next, we have the network layer protocol. Here, the network layer is called the internet layer. The internet layer protocols that actually defines the rule how to find the routes of a packet to the destinations. So in the internet layer, you can define the from one point of node to the another point of node how the packet can be delivered. So it defines the rule how to find the route for a packet to the destination. It only gives the best effort delivery. Packets can be delayed, corrupted, lost, duplicate, or out of order. So it actually provides the routing function in the internet layer. And the major protocols here are the IP, Internet Protocol, ARP, Address Resolution Protocol, or the ICMP, Internet Control Message Protocol. ICMP is actually responsible for the ping command. Whenever you go for the ping of any of the network address, it will give you the if there is any connection, it will give a corresponding reply to that. But if it not find the designated IP address, it will give a different types of different types of command. So ICMP is mainly responsible for the ping command. ARP, Address Resolution Protocol, that is actually responsible for IP to MAC or MAC to IP. So that is the main function of the ARP, Address Resolution Protocol. And IP protocol is the internet protocol that actually give the IP addresses. So now we come to the basic concepts of the IP addresses. As the name suggests, the IP address is a common term, a numerical name that is assigned to devices participating in a computer network. So every one of us know about the IP address because every second or every minute, whenever there is a network problem, whenever there is any problem, we need to check the IP addresses. So each machine on the internet has an unique identifier number called an IP address. So in the internet, each machine is identified by the unique identifier for the IP address. So as the name suggests, IP address, a name indicates what we seek, and address indicates where it is. A route indicates how to get there. So IP address is actually give you the three of them: what we seek, where it is, and how to get there. So IP address is an address, but by which we can able to reach to the next node. Subnet mask. Whenever you go for the IP address, at the beneath of the IP address, we see something like 255.255.255.0 or something like that. The subnet mask, that is called the subnet mask. A subnet mask is applied to the host bit to determine how the network is subnetted. That means that in a IP address, there are actually two parts are there. One is the host part that defines how many hosts can be accommodated in the IP, how many hosts can be accommodated, and there is also a network part that defines how many networks can be accommodated. So these are the two parts that form the segments of the subnet. So these two forms the subnet, host part and the network part. Host address of all bit set or no bit set, whole host address of all bit set that indicate a broadcast address. Broadcast means the packet is sent to all hosts. That is called the broadcast address. So IP address version. So currently we are using the IPv4, and we are also using the IPv6 because the range or the the range of IP address that is used in IPv4 that is being exhausted. So as the people are getting more acquainted with the internet, they are using multiple devices and that is connected to the internet. So we have a shortage of IP address in the IPv4. So that is why we are actually coming to the IPv6. In IPv4, that is the 32-bit number. So here the IP address is around 4.6 billion, and in the IPv6 that is 128 bit. So the huge range of IP address that can be able from the IPv6. So that is why currently we are actually migrating from the IPv4 to IPv6. So next we come the public IP address. So it is a concept that is called the public IP. In the IP address, there is a concept that is called the private IP address. Another is called the public IP address. Public IP address means the IP address is when you connect to the internet, what you see whenever you connect to the internet, the IP address you got from the ISP, that is called the public IP address. Means, suppose whenever you connect to the internet, you got one IP address from the internet service provider. That IP address is called the public IP address. Public IP address is actually given by the ICANN and the IANA group, and IANA allocates this address range to the regional internet register. Each RIR then further subdivides this address to the local internet registries, that is called the ISP. So first the ICANN and IANA, they divide the public IP address because you need to distribute the range of IP address to the across the geographical segments. So each segment has to give a range of the public IP address. And why the public IP address? Because otherwise the public IP address, without the public IP address, we will not be able to connect to the internet. So that is why the public IP address that cannot be repeated, that is in great demand. So, and from the RIR, we have the NIR or the LIR. So that is how the IP address are getting segmented. And from the ISP, we actually get the IP address. So here, this is the basic format of the IP address, a IPv4 address, 172.16.254.254.1. This is the typical IPv4 address, and why IPv4 is called the 32-bit, because each octet is actually 8 bits. So there are 4 octets are there. That is why it is called the IPv4, and 8 into 4, that is the 32 bits. And in IPv6, you have the 8, we have the 120 bit, 128 bit. In IPv4, we have the 32 bit. In IPv6, we have the 128 bit. And IP address is divided in the host part and the network part. So what is the host part and what is the network part? That is actually given one. I have given one example. So this is the IP address 192.168.254.0. So this 0, that is actually the society number or the area name. That is the network address. Means whenever actually going to a particular area or particular society, that is actually the network address. In a network address, there are several hosts are there. That is actually the flat number or the block number. Okay. So network address is actually the accumulation or the actually the bunch of a host address. In a network address, we have a bunch of the host addresses. So 192.168.254.0, this is the this one is the network address, where the host address is the 192.168.254.1 to 54.2. When we particularly identify one host means one node or one computer system. When you particularly identify one node or one computer system, that is called the host address. And network means where all the hosts actually of a particular area of a particular organization actually resides. That is the network. So the network address is synonymous to the society number, and the host address is synonymous to the flat or the block number. So IP address, the true principal function is that host or the network interface identification and the location addressing. And it is used for communication between nodes. As we know that, because without the IP address, no communication can take place. No communication can take place. So other than the private addressing and the public IP address, there is another two types of addressing, that is called the static IP address and the dynamic IP address. Static IP address means where you need to manually put the IP address. You go to the network sections of your computer, and where you manually put the IP address. That is called the static IP addressing. Address given manually and statically should be compliant with local network, should not be duplicate. So that is the static addressing. And the dynamic addressing, where the IP addressing is done through the DHCP server. Means you did not have to configure the IP address. It is the IP address is configured automatically through a server that is called the DHCP server, where you get one IP address automatically. So you need to check the option obtain an IP address automatically. So this one is the IP address, and here in the beneath of the IP address you see the subnet mask, and then we have the default gateway. Default gateway means whenever we mention one IP address, we need to mention whenever the IP address is communicating in which route it will communicate with the other devices. Suppose you are in a room, and whenever you are going to another room, you need to have one door. You need to have one door so that you come out of the door and able to go to the next room. So similarly, in the IP address, it also needs one gateway by which it comes out of that particular system and go to the another system. So that is called the gateway. The private addressing, is like that whenever we are not connected to the internet, we are actually concentrate on the sharing of files within the organization, not outside the organization, and we are not connected to the internet. Then only the private IP address comes into play. So the three range of IP address that is of private use: 10.0.0.0 to 10.255.255.255, 172.16.0.0 to 172.31.255.255, 192.168.0.0 to 192.168.255. So these three ranges are actually the range of the private IP address. And beside these three IP ranges, all IP address in the IPv4, that is, are the public IP address. So because in the public IP address, you cannot able to duplicate one IP address to the another, because in the internet there is single public IP address across the internet, because otherwise there is a duplication and one node cannot be identified. So that is why in the private IP address within a organizations, the IP address cannot be duplicated, but outside the organizations, the same IP address can be duplicated. But in the public IP address, whenever we use the public IP address, the public IP address cannot be duplicated. So that is why we need much more amount of public IP address, so that we can able to connect lot more of the devices. But in private IP address, that is used for local LAN communications, and it is used for the local organization purpose and for file sharing. And in the organizations, the same IP address cannot be repeated, but if you go to the other side of the organizations, you can able to form a similar network group in the outside of the organization. So that is the basic difference of the private IP address and the public IP address. So the classes of the IP address, we have the class A, B, C, D, and the E. So there are different classes are there. There is actually the 5 classes are there: A, B, C, D, and E. In the class A, where we have one network and the 3 hosts, one network and the 3 hosts. So here in the class A address, actually the host reach, we can able to get a huge number of hosts from the class A address, and it starts from the 1 to 126. Means if the first octet starts from 1, hello, sorry. So we have the IP address of the class A, that is of the class A, and there is one network and the 3 hosts, and it ranges from 1.0.0 to 126.255.255.255. So the first octet will start from 1 to up to 126. So if we see an IP address that starts that is actually between 1 to 126, that is a IP address of the class A range, and it has 126 different networks, and it has the total number of hosts is 16,777,214. So this is the class A IP address. The class B, where we have the 2 network and the 2 hosts. 2 network and the 2 hosts means here we have a equal number of networks and the equal number of hosts, and the ranges started from the 128 to 191. So any IP address between 128 to 191, that is the class B IP address. Here we have 16,384 different networks and 65,542 hosts per network. So it is actually used for the medium category organization. The class A is actually used where there is a requirement of huge number of hosts, and class B is actually used when there is a medium category organizations where the host is limited per network up to 65,000. Class C, that is actually used in the smaller number of organizations where we have the 3 network and the 1 host, and it starts from 192 to 223. 192 0.0.0.0 to 223.255.255.255. So here we have per network we have hosts only 254. So that is the limitation of the class C network. We have only 254 hosts per network. The class D, which is actually not used in the networking, it is actually used for multicasting. That is in the actually in the video conferencing, it is actually used. So here the range is 224 to 239 and used for multicasting. And here we have the examples like 224.0.0.10 and class E that is used for experimental purposes. So these are the major classes of the IP addresses from class A to class E, A, B, C, D, E. And why this classification is important is that from the IP address, we need to know in which class the IP address belongs to. And then only we can able to know how many network nodes, how many host node can be possible from that particular IP address. So that is why each segment of the IP address, each segment of the IP address classes is equally important. So class A, B, and C is actually used for the networking, and class D and E is actually class D is used for the multicasting purposes, and class E is used for the experimental purposes. So we come to some of the practical sessions here. So here I come to the practical session of finding the IP addresses. Means all of you know about how to find the IP addresses. So the public IP address, what actually I am talking about, whenever we are going for the public IP addresses, we need to go to the Google, and here we need to type what is my IP. So you see that that is the 14.139.223.153. This is the public IP address of the particular machine I am actually using. So this is the public IP address, and whenever we are going for the private IP addresses, we go for the network settings. There are also possible from the commands also. So here we need to go to the change adapter settings and adapter options. And here we need to go here and we need to go to the details. So here we see that the IPv4 192.168.3.32. So this is the private IP address. So the first one, what we see, that is the 14.139.223.153. That is the public IP address. And from the networking console, what we got, the IPv4 address, that is the private IP address. So the significance of the public IP address is that whenever we got the public IP address, so if we copy the public IP address, and if we go to one of the sites that is called the networktools.com, so it is actually a lookup tool that we actually look up the public IP addresses. So here we actually go for the who is search, and then you press the option go. So if we go downwards, if we see that it will actually able to identify if the IP address belongs to Center for Development of Advanced Computing, CDAC, and is also able to identify the address plot E2 by 1 block GP sector 5 Bidhanagar Kolkata 791, and the mail address is also there, ashok.bandapadhyay@cdac.in. And here we can able to find the ISP, that is the NKN, National Knowledge Network. The address is also there. So that is why the public IP address is hugely relevant in tracking the cyber crime. So whenever we are actually tracking the cyber crime, we need to identify the public IP address, because with the help of the public IP address, we'll be able to track from which location the crime actually occurs. So that is the relevance of the public IP address. And the private IP address is only used for the local LAN communication. That is inside the organization, that is used for the local LAN communication. And we will not be able to trace the private IP address. हम प्राइवेट आईपी एड्रेस को ट्रेस नहीं कर सकते, बट पब्लिक आईपी एड्रेस को ट्रेस करके वी विल बी एबल टू आइडेंटिफाई द लोकेशन फ्रॉम वेयर द कंप्यूटर वाज एक्सेस्ड, फ्रॉम वेयर द क्राइम एक्चुअली occurs. So this is all about the sessions. So if you have any queries, you can ask me. So if you have any queries, you can ask, or you can write in the chat box also.
Sir, there is a question. There are incidents that hackers hide or modify their public IP as well. How
There,
that possible?
so so there is a question is that Barun Gupta, that there are incident like that hackers hide or modify their public IP as well. How that is possible? Yes, that is possible, because there are already uh, means different like sites are there, proxy sites are there. Also you can use that VPN there, where you can able to hide your original identity. So if you use the VPN or the proxy sites or the browsers like the Tor browsers, where you can able to hide your original identity, and you can able to uh, give a duplicate public IP, means you are actually browsing from India, but you are actually given an IP address from USA or UAE. So whenever the investigator got an IP address of the US and UAE, they will thought that the crime actually occurs from the actually occurs from the attackers from the US or UAE. So that is why the VPNs are there. There is the proxies are there, by which the public IP address can also, means the IP address can also be hidden or can be modified. In that case, how the identify of those persons are identified? In that case, it will take some time, because we need to know that if the particular IP address, we need to know which proxy server or which VPN the IP address is actually allocated to. So we need to communicate to the particular VPN or to actually the particular proxy sites. And then if the particular proxy sites or if the particular VPN service provider gives the log, then only we can able to identify the particular person. So these are the challenges, because uh, as the as the cyberspace is growing, the challenges in the cyberspace is also actually growing, because here you need to identify the actual person, but there are different methods are there by which one can actually able to hide himself. But there are different tools are also there, but it is actually requires a lots of time to get the answer from the particular site, particular proxy site or particular VPN site, so that we can able to analyze that. Any other questions? So thank you, everybody. I think there is no more questions are there. So thank you, everybody.